I don't know, but I put them up anyways. So 14.1 we're on now. Talking about exponent. Oh, by the way, to remind you, this is good because I almost forgot. In our Schoology class, we're gonna do a problem today that we're not gonna be able to like take a super long time on. If you have issues on this problem, go to our class materials. Go to this chapter, other types of functions. Okay. That's fine, but all I'm trying to say is there's a video in there of me walking through how you can plug in the tables into your graph and how you have it tell you the exponential formula based off that. So if you get stuck on your homework trying to put those tables in your calculator and then make the exponential based off that, it's an 8-minute video that I recorded just this morning. Check it out if you have any issues. We'll try to come back to Schoology here in a minute. So we can rule out reflection. What if it's a translation? What should I be able to check if it's a translation? Something has to stay consistent for all instances. Robert?
Doesn't the slope has to be consistent?
Yeah, the slope would have to stay the same, but that's really hard to approximate when we're dealing with exponentials because slope we can only look at any one given point. There's not a consistent slope. So that'd be pretty difficult. If I translate, what's another word we use for translate? What's a synonym for that?
Move.
What?
Move.
Move. Give me more.
Reposition.
Move in what way? Greg?
Position.
Okay, but how so? Give me details. I can do what types of translations? Ben?
Any rigid movement.
Any rigid movement. Give me. So what are rigid movements?
Up, down, left, right.
So I could go up or down, vertical translations, or I could go left or right, horizontal translations. If I were to guess, would this be a horizontal or vertical translation if it's a translation?
Yeah.
Do you think G is higher or lower than F? Or do you think it's been moved left or right? Left or right, right? It probably looks like it's a horizontal translation. So what we can do to check is it a translation is look at any given x point, relate its y point, and then find out the same x value on the new graph. What's the y value? So here when I look at x being -1, my y is 1. Now when my y is 1, my x had to be 1. Now when my x is 0, 2, for my y to stay 2, because if I'm not going up or down, I'm moving left or right, so it's going to change the x. So I moved to the right 2. Again at 1, 4, I move to the right 2, and I get 3, 4. I can keep doing this for any point on the graph and see that when my y's are equal, my x for graph G has just been added to the x value of f. So what we see is G is really a translation 2 to the right from the graph of f, and we're going to look at how we would be able to do that if we have the parent function, what we would do to the parent function in order to make that happen. So your main rules right here on your paper, your basic parent function is b to the x. Now, did I introduce Desmos to you guys last week? Yeah. That's what I thought. If we go into Desmos and I look right there in your concept summary, you have ab to the x minus h, then plus k, right? I can assign sliders for all of these things. I can give ranges to my sliders. I can decide what the value, like the range of k could be. So -10 to 10. I can see what shift that does. Well, obviously, if it's a constant being added on, k does start to represent constant. A.
And then we have many C's.
Yeah, but when I make that B, for some reason Desmos doesn't like B. Yeah, earlier it changed it to C. I don't know why it did that. So we can see what happens as I change B. What happens to the graph? What happens as I change A, my coefficient? And then what happens as I change X?
Wait, did H?
Sorry, H. It's X minus H. As H gets higher, I'm going left. As H gets lower or negative, I'm going, or sorry, I just said the wrong thing. When h gets higher, I'm going right. Yeah, h gets higher, I'm going right. H gets lower or negative, I'm going left. So we're going to come back to this as we go through the lesson today. Desmos is sweet. So here's our first one. We need to evaluate what negative 1/3 times 3 to the x does to the parent function. The first thing we need to decide is what is my parent function here. So I want you on your paper to write down that our parent function is what? What is the original function that has been changed or manipulated? Jacob?
Y equals b to the x.
But we can't just have b to the x. We need to know what that value would actually be.
So it would be 3.
Yeah, so my parent function here is y equals 3 to the x. So what has happened is if we refer back to our parent formula of y equals a b to the x minus h plus k. So now we have an a of negative 1/3. Now we have a coefficient of negative 1/3. Where a originally here was 1, or just, we don't view it because it's multiplication by 1. We now make a be negative 1/3. So what we're saying is, what does a do to the function? Well, first thing we can do is make a table and compare values. So in your calculator, and I want us to practice how to do this, in your calculator you want to put both of these y equals situations in there. So I'm going to capture this really quick. So if you don't have a graphing calculator, grab one. We're going to put both of these y equals situations into my y equals menu. They're right here.
Oh, okay, I knew that.
So go to your y equals. We're going to put in the parent function first. So my first function is just 3 to the x. My next function, I will apply the negative 1/3 times the 3 to the x. Dead.
Like,
Thank you, sir.
I couldn't have killed it better myself.
Nice. With your crossbow.
With my crossbow.
So then if I graph both of these, now I need to check my window. My window's on a standard window. Ooh. So I have one graphs pointing up, one graphs pointing down. If we wanted to make a table of values, how do I do that? That table of values they have on your paper, how would I make that table of values?
Go like to the math, stat,
Not math.
stat.
All right, give me your eyes up here. How we would make that table. Go to second table set. So it's above window. So you really click window. Make your independent ask. You have to make your independent ask. Now go to second graph, which actually takes you to the table. And we're going to plug in the values -2, -1, 0, 1, and 2. And you should get the same values that we have on your paper there.
Wait, Mr. Hudson,
Yeah.
what was the y equals for the second?
So you got to use some parentheses. So you put negative 1/3 inside of parentheses because that's what's happening. We now have an a of negative 1/3, and then my still times my parent function 3 to the x.
Okay.
And you could actually put 3 to the x in parentheses if you needed, like if then anything else was added on or something like that. Because be careful, if I do 3 to the x and then I do like +4. I've seen this work out okay, and I've seen this work out poorly, where it adds the 4 to the x before it raises to the power, which is it's not how it's supposed to happen, but depending on how your settings are. So I put everything in parentheses, and you'll see that, especially if you watch my tutorial. So we can make the graph that way, or we can make a table this way. We should have the same values. Notice they give me decimal instead of fraction. It's okay. They're the same values. Any issues with creating any of that? Getting to this point so the calculator's spitting out your values. Yeah.
Wait, how do you get to the table?
So you go second table set, which is window. Make your independent ask and your dependent auto. Then go to second graph, which is table, and plug in the values for the x. Leah, did you solve a question?
Oh, never mind.
Okay.
Found it.
Are we good on this?
Find it.
So now compare these values, especially as we get bigger. So maybe we put 3 on here. Maybe we look at 4. Maybe we look at 5. I don't really like these decimal values, so I'm actually going to get rid of those. 0, 1, 2, 3, 4, 5, 6. What do we notice about my secondary y list versus my first y list? My first y list is my parent function. My second y list is my new function. I mean, it's on your notes, but what do we notice? We could just see this. How do these lists compare to each other? Yes, Seth?
If you multiply single by 3.
Not just 3. Negative 3, right? So what we see here actually is my second y list, my new function, is negative 1/3 of my old function, which makes sense because that's the math that I did. But when I look at the graph of it, that negative 1/3 flips it, it reflects it, the negative reflects it. What's the 1/3 do? Starts with a C. It's a compression factor. So what you want to write down here for what has been done is a reflection of the x-axis. And that happens because the negative, I know, then compression factor. Any questions on why any of that happens? The negative inverts on my value, so it flips it over the axis. 1/3 just cuts them all down by a factor of 3, so it's a compression factor. Of course, that compression factor actually widens my graph because it's a compression less than 1. So it's not actually compressing. It's, I don't even know what the opposite of compression would be. Not depression. Expansion? Expansion factor, probably. Any questions? Any issues? Cool. So let's try the got it and relate our new graph, y equals negative 0.5 times 5x. We want to write down what's the parent function. What is my parent function? Ben?
Y equals 5 to the x.
5 to the x. So what's happening is we're applying a coefficient value of a negative 1/2. We should be able to anticipate what's going to happen. But if we want to do it in the calculator, we again put both lists in. Yeah.
How do you do to the power of x on this?
You use the caret.
And then x.
There's a carrot?
So
We've been using caret since 8.
if this will turn on again.
Since math.
So check it out. I'm now going to change my parent function to 5 to the x. I'm going to go down and do negative 1/2 times 5x. Notice I can just replace these values. Watch what's nice and easy now. When I go to my list, or sorry, my table, second table, all my independent values are still there, and my dependent values now change based off the new functions. So now, if I compare my first list to my second, well, that's a 1/2 negative. That's a negative 1/2. That's a negative 1/2. That's a negative 1/2. Well, that makes sense. But when I compare the graphs to each other, again, what's really happened now? And this, again, is why I'm recording all this. If you get lost, you can go back and watch this later. So what happened? It's pretty much identical to the last one, Ben.
Just multiply by 0.5.
Yeah, but so the graph, what effect does it have on the graph?
It's just getting reflected.
So my negative reflects the x. And we have a compression factor.
I didn't hear what you said about the compression factor.
So, if all I had was y equals negative 5x. I would get the exact same exponential just flipped over the x-axis by the fact that we now have y equals negative 1/2 to the 5x. That now actually opens up my graph a little bit because all these values that it spits out are going to be below the x-axis and half of what they were before. So it changes the steepness of my graph. That's what we call a compression factor. So if this was over 1, it would be like making it steeper, but since it's less than 1, it actually kind of makes it wider. And it depends on whether we have y equals or x equals. So think about like every y will now be half as far away as it would have. So instead of being as far down here as it would be, it'll only actually be here and then half and then half. So it makes it wider since they're all half of what they would have been.
You mean less one?
It makes the graph more like this, less like that. Because they're all half what they would. Yeah. When it's a compression factor of less than 1, whether it's negative or positive, it doesn't matter. If it's less than 1, it widens, it opens up the graph. All right, we have a lot more to cover.
Are we gonna like continue this with tomorrow or something?
Potentially. I have to be out on Wednesday.
In this
so I
problem,
probably
you will
have you
translate
guys
graphs
work
of
on
functions
some
of the
video
form
for you
y
guys.
equals a times b to the x power.
So what
How
I'm
does the
gonna
graph of the
request
function
is
compare
you
to
guys
the
have
graph
them
of the
on
parent
Monday.
function?
All it's going to be is get a Chromebook, get some headphones,
Part
and
A.
do your work.
The first function is y equals 2 to the power of x minus 4.
We got to keep moving forward. So now, instead of applying a new coefficient to the parent function, now I'm going to apply changes in the exponent. So, what would be my parent function here? Yeah, Leon.
2 to the power of x.
2 to the power of x. Make sure we have the y equals.
Isn't the minus 4 shift it horizontally?
Ah, you are correct. That would give me a horizontal shift. So any change to the exponent is a horizontal shift. Guys, you can refer back to on the front where it shows you this table right here is gold. It's gold. It's valuable.
Oh.
B minus H, horizontal by H. A plus K, vertical by K. It tells you everything you need to know out here on that little table on the front. So if we're back here, we see that the parent function is 2 to the x. When I graph these, I did not graph both for you. When I graph these, my exponent now is subtracted by 4 before it's applied. So we have to figure out what are the values going to be at those points. Well, let's set up a table in your calculator. So you need to plug in y equals, and you could do the original function, but I've given you the tables for the original functions. So you could just do the new function. So if we do that, it's going to be y equals, I'm going to clear out my other graphs, 2 caret parentheses x minus 4. Close your parentheses. Go to your table. Now I want to find values to go with -2, -1, 0. You guys should be doing this with me because it's not done on your paper. And then 1, 2, 3, and I can just clear out this last one. Now, if we go over to my 0.15625, anyone know what fraction that would actually give me? Is it 136? So, if we don't know what that fraction is, do the math manually. This just relates to if I plugged in -2 up here. Well, -2 minus 4, so this would be 2 to the -2 minus 4, or 2 to the -6. Remember what the negative exponent tells me to do? It's really 1 over, because the negative exponent tells me to take it to the denominator. So it's really 1 over 2 to the 6th. So those values are kind of hard to work with, very, very small. Let's use some values that I can actually use. So like 0.0625. This is a decimal value that we should recognize. 0.0625. What fraction does that relate to? 5/8. Thank you, Greg. So 5/8. 0 would be 5/8. Fine. So we're a little bit under this point here. Try to put a point for 5/8 on your graph. 1. Is that a y value? A 0.125.
No point. That 1/8.
That's 1.
Sorry, 0.625 would have been 5/8. We're at 0.0625. Sorry, we misspoke. That was not 5/8. You're close though. Not 0.0625. 0.625 is. But we have an extra 0 in the 10th place. So if we have an extra 0 in the 10th place, what that actually does is give me an extra 0. So Greg, it is 5/8, slightly off. And smarting may not work on there. Instead of being 5/8, it's 5/80ths. We put another 0 on the bottom. It shifts my decimal places. So this should actually be 5/80ths, so it's almost on the line, like almost at 0. Pretty much as close to 0 as we can get. Then 1/8. My smartboard's off too, which is not helping anything. Then at 2, I get a 4th. Still as tiny as possible. Can't draw. So maybe we need to take some bigger values. At 3, I'm at a half. Finally, I seem to be able to show that. What about 4, though? Let's use a 4. I get a 1. Thank you. We finally have integers. What about 5? I get a 2. Okay. We're looking positive now. Then if I plug in a 6, I get a 4. Now I'm climbing. Then if I plug in a 7, I get an 8.
Mr. Hudson,
Yeah.
look at the, if you know that it just shifts it horizontally 4, couldn't you just do that?
Yeah, but we're just trying to see that it, like, why it happens. We're just trying to show it. So each and every one of these should be a shift of 4. So just remember, what happens in the exponent is counterintuitive. This shifts it right 4, even though it's minus 4, it shifts it right 4. It does the opposite of what you think it's going to do. Minus 4 shifts it right. Questions, comments, concerns?
Is this supposed to be easy?
It depends on how your brain is wired. If you're good at like evaluating the graphs and determining what happens when I do whatever, if you're still struggling, I would take some time to play in Desmos, like literally just play and just watch what happens as I change certain values. Like I can take this 20 times 1/2 x plus 10 and I can put it in Desmos, except when I do that, a is now 20, so I need to make this allow me to go to 20. 20 times, what is it, 1/2? Sorry, we're in the PDF now, aren't we? 1/2 to the x, then plus 10. So now my b has to be 1/2. So there's half. A has to be 20. Was there anything in the exponent? Nope. And then k is plus 10. So make my k value plus 10. So we can see, well, wait, if I didn't have the plus 10, okay, so what's that k doing? It's just shifting up and down, right? So we know that plus 10 is a vertical change. What about my a, though, that 20? Well, if I make that 20 go all the way down to 1, because once you go below 1, then you get really goofed up. So that's why I have my a slider lock at 1. What's that really doing? Well, if I can't see, zoom out. I can zoom way out on the graph.
You should probably fix your H. It's at negative 7.3.
Oh, yeah. We want my h at 0. Thank you. So I can zoom back in. Good catch. What's my a really do? It's not actually, because we know horizontal shifts have to come up here. Vertical shifts have to come right here. So the a has to be compression factor.
Compression, yes.
So how does the graph compare? Well, we could label compression factor of 20. Would it have flipped, reflected anywhere? Does it have a negative in the coefficient? No. So it does not reflect. So the only other thing it does is what? What's the plus 10? Yeah. Vertical shift of 10. Plus 10. And again, there our parent function is just 1/2 to the x. Just my base to the exponent. That's my parent function. So just to practice this in your calculator, go into your y equals menu, plug in this function as your y equals function. We do not need to compare it to its parent function. We just want to look at the values. Then make a table of values to find out what is it at -1, 0, 1, 2, and 3, and then plot those points on our graph. So we go into our y equals menu. I'm going to talk it through while I do it. If you want to ignore me, totally fine. Clear this out. Make it 20 times, not 21. The calculator's slightly skewed for my mouse clicks, so that's where it gets goofed up. Times 1/2 to the x. Now I'm actually going to add an extra set of parentheses around the whole thing before my vertical shift. But we could see what happens if I don't have one. So I could do that again without parentheses and see, will it come out to be the same? Am I doing extra work? Am I being too cautious? Sorry, yeah, my clicks are off a little bit. To the x. So I'm going to check, are these the same? Plus 10. Ooh, neither graph is on there. So instead of bothering with the graphs, let's look at my table values. Does it come out to be the same? Yeah, they come out to be the same. My calculator knows apply the exponent before performing addition. But I never let the calculator make assumptions. I just add in parentheses. So you don't need both of these. You only need one. So let's make a table of values. Start with -1, 0, 1, 2, and 3. Yeah? You're still what?
Me?
Yeah.
No, I thought you said that we didn't have to do anything with this anymore, so I cleared it. So I said thanks. But,
So either I cleared one of mine because I was done. So with this table, I know enough of my values to start my graph.
He died.
No, you didn't. Come on. Where's your issue? Did you fill in your values? Did you collect points? Where's your pencil? There's something on the floor beneath your right foot. 50, 30, 20, 15. And 12.5.
Whoa.
What do you notice about the change in my values? From 50 to 30. Jake? The change is always half what it was before. I go down by 20, then I go down by 10, then I go down by 5, then I go down by 2.5. What is that an indication of? Exponential activity. Whenever my change is halving every time or doubling every time, I know it's exponential activity. So I then plot these points. -1 is at 50, so I need to keep labeling actually. 10, 20, 30, 40. 50 is actually off my table, so I can't label that one. Yeah, well, it'd be like up here. Then 0, 30. I'm going to start plotting in red. There's my 0, 30. 120. Pay attention that your scales are way different from each other. 2 and 15. 3 and 12.5. Could you anticipate what 4 would be? 11.25. So 4 would be 11.25.
Right?
Yeah, you're right.
Oh yeah.
Then we go down by half of that again. So now we go down by 0.625, right? Because we had like 1.25, essentially 12.5. We can kind of. Well, if we went down by 1.25 and we half that, that's going to be 0.625. Because think about it as 12.5. Just shift the decimals around. So now I go down by another.
But how does 25 happen at 25?
Because if I think of this as 12.5, half of 12 and half of 5. Half of 12 is 6. Half of the 50.
Okay, I see.
Yeah. Yeah.
For 3, you wrote down 12.5.
Oh, what was it? I think it was 12.5.
Yeah, it's 12.5.
I got 12.5.
Oh yeah. Oh, sorry. I thought we were graphing the phone. I forgot that you're adding 10.
Yeah, we're. Oh, yeah. So this.
Yeah, because the graph was confusing.
Sorry, this I am doing it with my plus 10. Go ahead and write that in. Sorry, I jumped us right to that. Big thing is we shift it up by 10. So what you would realize here is your asymptote shifts up to y equals 10. So you would also want to add the plus 10 over here since that's what we decided to graph. And if I model this with an exponential, it should look like your asymptote is coming.
You should say angle side.
Now, if we graph just the parent function, that would just be 10 below. So right there, right here, right there, right here, right there, with the asymptote being 0. It will grow ever closer to 0. Now this next section, I knew we weren't going to have a ton of time, so that's why I recorded a video on it. Let me check right where we are. At the bottom of the page. Hey guys, please stop talking in between what we're doing. What shift would this do to the parent function 4 to the x? What shift does plus 2 do, class? Where the 2 to the left? It's counterintuitive. If this is a plus 2, it goes left 2. You need to label that there so you do not make that mistake. It's counterintuitive. It does the opposite of what you think it should. And there's mathematical reasoning behind that. Right here, I'm going to save my breath and hope that Schoology is working.
Schoology.
Just to refresh.
You guys like skipped it.
Get your calculators out and get ready to edit lists. If you can find it on your own, good. If you can't, you might need to think back about how much have I been doing with this. Hey guys, I thought I would really quickly run through one of the example problems from today in class just to help you understand how to put this stuff in your calculator a little bit better. So here we have problem number 3 that said we want to use our exponential model to... So I'm going to come around and help you guys as we go, but the first thing we're going to do is edit lists. Actually, this is probably going to be harder if I let that play. All right. If you get stuck tonight on your homework, go back and watch this video. It's actually pretty good. I like that I can use the calculator and everything at the same time. What we want to do to make this happen is go into your calculator. On problem 3 now. Go into your calculator, hit the list button, but actually it's stat, but it is the button that controls your lists. Just hit stat. You don't need second or anything else, and go to edit. If there's anything in your lists, clear them out. And it's easiest to clear if you go up to the L1 or L2 or something, hit clear up at the top. It's much easier. Then input these two lists. So 0, 5, 10, 15. Anybody having issues finding your lists?
I only have L2. I don't have L1.
Tap to the left. Your screen has probably been shifted.
That takes me to L6.
So everybody should be plugging in their list. Gentlemen, where are your calculators? Why are you not plugging these in?
Go all the way up to L2. And hit Q and then hit it.
Or you just
No, because not yours is not one of the fastest.
So all of yours will just shift the name by 1. We're just grabbing the calculator really fast.
I'm entitled to not shutting up. No.
So if you hit second RCL, like clear all the way back out, like do quit. Second RCL should clear everything out.
Are we just enjoying smacking each other?
Gentlemen, why do you consistently act half your age? Try to follow the process. Do your next steps. If you can do them without my assistance, then you can do whatever you would like. This reset button. Yeah.
How do you get to L1, L2?
Hit stat. Just do this with all of your lists. Just add 1 to your coefficient of the list. So instead of list 1, you'll be list 2. Just add 1 to all your list names. Or and then edit. You just go to edit your lists.
Okay, well, this is my
Here.
so here's me.
Now you have L1s.
Thank you.
Yep. Emily, do you need a different one?
No, this is mine.
Okay. If it's yours and it's being goofy, come work with me later if you want. I can try to fix it or reset it. So we should have all our values in here, 20, 25. I know, it's because my clicks aren't accurate to where they're supposed to be. Frustrations.
Oh my.
Everybody in their lists editing. Anybody having issues with that? Oh my gosh.
Oh, I get it.
Everyone have your 2 lists. Probably quicker than me because I'm working on the computer and it's harder than punching buttons. Now, what we want to do, and if you look at your notes sheet, it walks you through this. We want to plot this. How do we plot our points? Well, we go to plot. So notice above your y equals says stat plot. So hit second y equals to get to stat plot. You're going to go into plot number 1 and turn it on. You're going to use the lists L1 and L2. And the box is the easiest thing to have it plot with. Notice if I go to my graph, it is not there because this is a 10 by 10 graph right now, or really 20 by 20, but only goes up to 10. So we need to go into our window, hit your window button, change your X-min to 0, and the max 40 will go over our amount of time just because it's easier that way. It's nicer to see. And we'll make my X scale 4 just because it's 1/10 of the distance. What's up?
Whenever I hit graph, it just says window range.
That's exactly why I'm describing how to change your window right now.
I know, but I did change to this and it's still.
You probably did not. You probably have an error in how you changed your window. Your scale is bigger than your work with us, okay? Then my Y scale, I'm going to make it 0 up to 220, and then just make my Y scale 22. Make sure that your window matches this.
Whoa.
220, what?
Yeah, because my biggest value is 207, but I'm just going to go higher than that just so it all fits on nice, easy. Now hit graph, and it graphs it. Notice I have a line here that I shouldn't. I did not clear out my Y equals menu. But when I go to graph, I've got this. Now, we are out of time. I've already taken up a little bit of your guys' lunchtime. The rest of this process is on the video in Schoology. So, as part of your homework, you need to go on Schoology and watch through the rest of this. We will finish running through this later. I actually do not have your homeworks right now, so I will bring them down to you guys later. I'll come find you.
Alright, who hates
Or come visit me after lunch.